that bats are really unique mammals because they're the only ones that have been able to achieve powered flight. And because of this, their upper limb bones have been modified into these flexible wings. And this really allows them to sort of bend when they're doing complex aerial maneuvers. Historically, it's been quite difficult to reconstruct the 3D architecture of bat bones. So our team used the biomedical imaging and therapy beamlines, or BMIT, at the Canadian Light Source. And using the synchrotron, this uniquely allowed us to create a full three-dimensional map of the vascular canal network in various bat limb bones and of bones of various sizes. So when I talk about bone, I always explain to folks that it's a living record. So it's a really dynamic tissue that's constantly changing in response to growth or injury or biomechanical pressures over an animal's life. And the same is for humans. A lot of the imaging methods that we develop for, say, animal bones can be applied to the study of human bone tissue as well. So again, having a setup that allows us to image the bone non-destructively is really critical in cases where, we have a museum specimen. Folks have imaged dinosaur specimens, for example, fossils, and looked at the vascularity of baby T-Rex. So for me, I always want to reiterate the importance of bone as a dynamic organ, right? So I mentioned that you can think about it as a living record. It records aspects of our lifestyle, not only our locomotor pattern, but in humans, for example, the substances that we ingest, our food, if you are a smoker, all of this impacts the bone microstructure. So it can sort of be thought of as a series of steel bars that don't change, right? And that aren't flexible. But bone provides so much more than just our skeletal structure. So we can learn a lot about physiology, about, again, what happens in response to different substances or lifestyle sort of choices from our bones. Again, we're just scratching the surface and really changing what we think we know about bone and how it maintains itself and how it adapts.